Hello YouTube, my name is Jay Kinsey and I've been a First LEGO League judge for a long time, and after seeing so many robots over the years, I just kind of wanted to build my own and try my hand at building a robot, because it's been many years since I've been hands-on with a robot in competition, so I figured I'd give it a shot and just see what happened. So this is the design that I came up with, and there's a couple of neat features in here which I think you might be interested in. So probably the first thing you'll notice, um, other than these two giant towers, um, is the EV3 brick here is facing down on this design. The reason for this is that this robot is designed to leave base and never come back. And by doing that, you reduce the amount of operator error that can occur. And in addition to that, by moving the EV3 brick into the position that it's currently in, it leaves a very open top deck for doing all sorts of things while also maintaining a low center of gravity and good balance between the front and the back. This is also designed such that this should take a rechargeable battery pack as well. Cabling might be a tad on the tight side, but it'll still do it. So that way you can save yourself a couple batteries. From the locomotion perspective, one of the things you'll probably notice is that I have NXT motors in here. Now, NXT motors are an interesting thing because the NXT motors actually have less backlash in them than the EV3 motors, and this is due to the configuration of the internal drivetrain of the motors. So you actually will get slightly better performance out of the NXT motors just for the sole reason of them having less backlash. In addition, they also have a little bit more torque, which is also very convenient. Attached to those motors are the wheels. These are this style of motorcycle tire. And what's interesting about this type of motorcycle tire is that the outside of this is hard rubber. And the reason why that's important is because that as this robot gets heavier and heavier and it carries more things with it to complete missions, the radius of the wheel will not change. And when the radius of the wheel doesn't change, it helps keep the robot more consistent in how it moves. The other thing I really like about these wheels is that it has this really convenient 6-bolt pattern, and rather than just connecting the wheel with an axle, there's actually a whole assembly in here which helps the motor actually apply torque to the wheel. So you can see here that we have, I'll move some of this for you so you can see, we have these pegs in here, and they alternate a little bit, and they go back, and they hold the wheel on, which is nice. But what's interesting about this design is that this whole face of the motor here, this 4-bolt pattern, bolts up partially to the 6-bolt pattern of the wheel. And by doing that, you're reducing the air in flex of the primary axle, because you're turning from this whole orange face to the inside of this hub directly, rather than going through a tiny axle. So it just gives you a little bit more rigidity, which is always nice. The other thing which is kind of cool about this is on the outside of the drivetrain, we have one of these Technic frames, and then we have this small subassembly here. Now, the small subassembly is meant to be a consumable part. So it turns out that if you run LEGO robots long enough and hard enough, you will start to wear out the axles. And so what this does here is that this little assembly will come out, and you eventually, the inside of this Lego part here will just get worn out. So it's easy to just pop one back in. So it's a very convenient consumable part to replace. Not that I would expect that to happen all the time, but it most likely will happen at some point. See, a couple other notable things on this machine are on the underside. We have the gyro sensor. The gyro sensor here is very low to the ground, and also it's centered over the axis of rotation of the robot, and it's a little hard to see with the ground plane on. Yeah, you can probably see that okay. But there's a little assembly here which uses these two long axles, which are made out of rubber, and it provides a little bit of suspension. And so I'm guessing that having the gyro just ever so slightly lightly suspended will actually help reduce unnecessary vibration, which might increase accuracy slightly. Let's see. While we're on the subject of sensors, we have the light sensors here. They also have a little bit of a shroud that goes around them as well, which is nice. These bearings that are all over the robot are general casters, but they're also wall runners as well. These four here that are being used as casters are actually a little tall, as you can see, and I'd have to build this to find out if this is actually true, but I'm not sure if the ball and these ball casters ends up riding high enough in this housing assembly to give this machine the clearance that it really needs. So this is one of those cases where you'd have to bind it, where you'd have to build it and find out, what the actual clearances on that are. If those clearances are incorrect, I would imagine that these attachment points here could be redesigned slightly in order to give it the type of clearance that it needs. But my hunch is that it should work. Now, for these casters that operate on the sides, these are here as wall runners to run along the side of the wall. The reason why that's important to use casters in this particular application is that you cannot guarantee the state of the table that you're running on in competition. And I have seen plenty of tables where the walls were made out of poor quality wood, or the walls were damaged, or any other number of factors that led to like a traditional wheel getting caught in the wall and then throwing the robot either off the wall or off course, and then the robot doesn't reach its intended target. So the idea of going with a caster as a wall runner is that as the robot runs against the side of the wall, the caster is free to rotate in any direction that it chooses, thus making the robot's body independent of whatever the state of the wall happens to be, regardless of quality. Let's see, what other factors do we have in here? Okay, so you probably are pretty curious about what these giant towers are. So these giant towers are actually the beginning part of what's going to be kind of a forklift. I don't have these installed here, and I have the geometry that I'm going to end up using in another file, but I haven't put it on here yet. There's going to be linear rack gears that run up and down all of this, and those linear rack gears are going to have a platform which goes across these two towers, and then a motor will power a couple of gears that will climb up and down these racks that will be placed on here. And so there'll be a big platform up here which can go up and down. Um, and that large platform in and of itself can be used as a forklift. But what I really want to do is on top of that platform, um, going off to the left and off to the right of the robot, I would like to have either six or four, six or eight sided turrets. So you could imagine a platform that runs across the robot that goes up and down, and then off on either side are basically, for lack of a better term, giant Technic Cinnabuns, as in cinnamon buns, that have a bunch of tools on them, right? And then those tools are um, meant to, you know, accomplish whatever the missions on the table are specifically. So the design philosophy of this is actually kind of based off of a CNC lathe, where you have a turret and all you have a whole bunch of tools attached to that turret, and then as you want to do different machining operations, right? You can choose a different tool on the turret. The turret rotates to the tool that you're interested in, and then you continue on your machining operations. This, when it's complete, will operate in roughly the same principle, where you'll have these turrets on either sides, which are going to look like cinnamon buns, um, with tools sticking out of them, and you'll be able to rotate to the tool that you're interested in. So by being able to go up and down, you have a forklift function. And then by being able to rotate your turrets, you have the function of an angular or axial arm, but you also have the ability to change tools to other things you're interested in. You would also be able to change tools to other sensors. So, for example, you could have an ultrasonic sensor as one of the tools, and you can check the height of different things as as the platform moves up and down. You could also do something where, and I've seen this done before, and I think it'd be really neat, where you take your ultrasonic sensor and you point it down, and you actually directly measure the height of the arm off of the ground. And that's really interesting because that's always giving you an absolute value of how high your arm is. I don't think it's super precise, but for the majority of applications, it might be at a level of precision which is appropriate for the task. Um, yeah, let's see. I'm trying to think if there's anything else here that is particularly notable. Um, I think that's it for now. Because yeah, we covered the wheels, we covered the casters, we covered the towers, we covered the EV3 brick positioning being on the underside. Um, yeah, so I think that's a wrap. Um, so I kind of would appreciate in the comments if if you have any particular thoughts on this design, if we have any feedback on what you think of this. I'd be curious as to what your thoughts are. So in the comments below, I'd be interested to hear what you think. So that's all for tonight, and I will be signing off. And tomorrow is a competition day. So have a good night.